Alright, so for 11 to 19, you have to, they're asking for the amplitude and period of each function. So for the first one, the amplitude is 3, and the period is 2 pi over 2, which is pi. For the second one, the amplitude is 5, and the period is 2 pi over 1/2, because notice the x is in the denominator. So when you simplify this, you get 4 pi. And the third one, the amplitude is 2/3. Period is 2 pi over pi. So that's 2. And that's okay. We just haven't graphed them in class yet, but it's okay to have a period without a pi. Number 17, the amplitude is 2. Remember, the negative just tells you there's going to be a reflection over the x-axis, but the amplitude itself is 2. On the period, 2 pi over 1, which is 2 pi. The last one here is amplitude is 1/4, and the period is 2 pi divided by 4/3. Okay, so when you simplify that, this is the same thing as 2 pi times 3/4. So I can reduce here, I get a 2 there, so it's 3 pi over 2. Alright, so we're going to graph a few functions. The first one here, y equals 4 sine x. So the amplitude is 4, the period is 2 pi. There is no vertical translation and no phase shift, so we just put that there. So now we're going to plot it. Alright, so in the instructions in the book it says to graph 2 full periods. So since the period is 2 pi, I counted 4 tick marks, and that's 1, 2, 3, 4, and that's going to be 2 pi right here. And the next period would be 1, 2, 3, 4 more tick marks, that would be 4 pi right here. So this would be pi over 2, 3 pi over 2, and then we could continue past 2 pi. So it's 5 pi over 2, 3 pi, and 7 pi over 2. It's a pi right there. Okay, now this is a sine graph, a sine function. So we know that the sine has zeros at the beginning, middle, and end of its period. Maximum is 1/4 of the way, and minimum is 3/4 of the way. And that's one period. The next period, the beginning is already there. At 3 pi is the other 0, and at 4 pi the other 0. At 5 pi over 2 we have a maximum, and at 7 pi over 2 we have a minimum. And then just connect. And there you go. Okay, and there's 2 full periods right there. Alright, so 46, we have an amplitude of 3/4, period of 2 pi, and no phase shift and no vertical translation. So again, we have a period of 2 pi, so I'm going to count 4 tick marks. 1, 2, 3, 4, that's 2 pi. The next period is 4 pi, because again they're asking for 2 periods. So every tick mark is pi over 2. Okay, and this would be 5 pi over 2, 3 pi, 7 pi over 2. Now notice how I labeled the y-axis just to make it easier to graph. So I'm just going to go up four squares for 3/4 pi. So for cosine, the maximum is at the beginning and end of the period. The zeros are at 1/4, 3/4 of the way, and the minimum is in the middle. So that'd be right here. Okay, negative 3/4. For the next period, we already have the beginning, so I just need to add the end, the zeros, and the minimum. And then you just connect the points. Remember for cosine that at the ends, don't go up at the end. It curves back down. Okay, so don't go. Same thing at the beginning. Make sure that you're coming in from the bottom up. Alright, so we have an amplitude of 1, a period of 2 pi. Phase shift is pi over 4 to the right. Vertical translation, none. Alright, so here's my axis. Notice I haven't labeled anything yet. First thing I'm going to do, because there's a phase shift, I'm going to divide the 2 pi by 4. So this becomes by 4. And I'm just about to reduce it to pi over 2, but then I notice that that's a denominator I'm looking for, right? We're looking for a common denominator. So every tick mark is a pi over 4. So remember, this is where I begin, and this is my increment. Okay, that's how much I'm jumping, how many tick marks I'm jumping each time. So the first tick mark is pi over 4. And then I'm going to skip every other one. And then that's going to be the, let me use a different color. So this is going to be the beginning, then here, and here, then here. So that's 1, 2, 3, one more. That's the end of the first period that I'm going to draw. Okay, then 1, 2, 3, 4. That's the end of the second period that I'm going to draw. So let me finish labeling. This would be 1, 2, 3. 3 pi over 4. 5 pi over 4. 7 pi over 4. 9 pi over 4. All odd numbers. 11, 13, 15, and 17. Okay, so it's a sine function, so the zeros are beginning, middle, end. So right here, beginning, middle, end. Maximum is 1, it's 1/4 of the way, so that would be at 3 pi over 4. Minimum is at 7 pi over 4. Okay, then the next period, beginning is already there, middle is here, end is here. Maximum happens at 11 pi over 4, and minimum at 15 pi over 4. Okay, and so here's the function. These are 2 periods. Now, if there's a right phase shift, I usually, it's common practice to just go back and make sure you reach the y-axis, so don't leave it like hanging like that. I'm talking about this part right here. See how there's a blank space? So if we were to continue, we know that the tick mark on the left would have been here, which would correspond to -1 right here. So I just continue and finish it off like that. Alright, so 53 has an amplitude of 1, but remember the negative in front of the sign tells you that there's going to be a reflection over the x-axis. Period is 2 pi over 2 pi over 3, which when you simplify this is 2 pi times 3, oops, that's like 27, over 2 pi, so that cancels, so that's 3. A phase shift, there's none, and a vertical translation, there's 1 up. Alright, so no phase shift here, so we can just count 4 tick marks, 1, 2, 3, 4, and label that with the length of the period. Half of 3 is 1 1/2, but I'll write it as 3 halves. And half of 3 halves is 3/4. So every tick mark is 3/4 units long. To get the third tick mark, you just multiply the 3/4 by 3, because it's the third tick mark, and you get 9/4. Notice there are no pi's here, and that's okay. It doesn't have to have, the x-axis does not have to have a pi. So 3/4. So I'm just going to go ahead and finish off the rest of the x-axis by adding 3/4 to the previous number. So right here for 3, that's 3 3/4, but when you write it as a mixed number, it would be, let's see, 3 over 1. I'm trying to, so 3 is 12/4. So I'm going to add 3 so that I get, oops, I'm erasing, sorry. It's 15/4. And I'm just going to be adding 3/4 on. So this would be 18/4, 21/4, and 24/4, which is 6, right? Which makes sense because it's 2 periods. One is 3 units, so 2 periods would be 6 units. Excuse me. So if you want, you can get rid of that one and put 6. Okay, so now we're ready to plot our points. This is a sine function. Zeros are beginning, middle, end, but oops, almost forgot. There is a vertical translation, up 1. Okay, so now we're ready to graph. So beginning, middle, and end. And then maximum is normally 1/4 of the way, but because of the reflection of the negative in front of the sign, it's actually a minimum. And then the minimum is now the maximum. So we're going to count. I used 3 squares for one unit. 1, 2, 3. So I'm going to put a right there. And so now we have beginning, middle, end. And what normally is maximum is now minimum, and what's normally minimum is now maximum. So connect your points. And that's it. 2 periods of sine. Okay, so for number 71, you have the maximum at 8 and the minimum at 0. So this is, the maximum up here, the minimum right here. So the midline would be at 4. So that means that the D value is 4.